All right, let's go ahead and get started. Good morning, everyone. My name is Cameron Purdy. I am going to be talking about Ecstasy. It's a language, not a drug. I got the question actually before we started, where'd the name come from? And years ago, I was working on a, shall we call a side project, just playing around with some virtual machine ideas. And I called it the XVM at the time, and the X basically being replaceable, kind of like a VXD for a virtual device driver or something like that. And at some point, some of the ideas started to come together, and it was less about this generic VM that could run anything, and it became more about a specific purpose, which we needed for a product that we're now building. And as a result, we ended up with a much more focused language VM design, and we needed, as a side effect of that, a language that would be capable of running on it. And since the virtual machine was the main thing we were focused on, and when we realized we needed a language, we needed, something that wouldn't suck. We wanted something that would be brilliantly good and attractive. So that's where XTC, XVM translatable code, came from, which became Ecstasy, the language. So just to quickly start out, this is not for your day job this year, probably not next year. This is a very long-term development project. Some of the ideas in the VM date back 30 years before I started working with Java, and it's very exciting. Everything looks cool. The demos should actually run, but there's a big difference between a demo and something you use at work. So I'll explain how some of this is. And I made up the version number. We don't have version numbers yet. That's how early we are. But I don't want to mislead anyone about what the state of the state is. So the design is very complete, but we haven't yet bootstrapped the language, which means at some point all the work we've done gets thrown away because we actually have to rebuild all of it in Ecstasy. And so we haven't done that yet. So who am I? Used to work at Oracle. They bought my company, Tangasol. I had built a product called Coherence. And for the last 4.5 years, I have been doing this, just Ecstasy and XVM. Start with a hello world, why not? This is what the code looks like. That's a module, that was easy. Now a module can be one file, it can be one line of code, it could be 1 million files. And in fact, both of those are interchangeable. You could take the 1 million files and cut and paste it together and make one file, and you'd have a one-file module, but it would be pretty ugly, and your version control system would hate you, so don't do that. Does it look kind of familiar, other than the fact that nobody likes where I put my braces? Does it look like any language you might know? So one of the greatest brilliant things behind a language called Java that you've probably heard of is that they picked all of the idioms from the major language of the day, which was C, C++. And so if a C++ developer looked at Java, they thought they already knew it. In fact, I downloaded JDK 102 beta back in, I think, end of 95, early 96. And inside half an hour, I had written a GUI application running in a web browser from scratch. And I thought that I knew the language. Now, obviously I didn't. It took another 10 years before I really knew it well enough to think I knew it. But it was just brilliant how everything I knew from C++ was obvious in Java. It's like, hey, let's take the good stuff and cut them. Filtering language. Cut the bad parts out, which is, of course, 98% of C++. So, big picture goals. What do we want to do? Like I said, it should be really obvious. If you know C#, if you know Java, C# being Project Cool, which was Microsoft's cleanroom copy of Java. So, C#, Java are really the same language. They just at various times try to outcompete each other by shoving in features before they're ready. If you know Java and C#, this should be a no-brainer. This should be easy. Modular, we started from the ground up about modules. Like if there's anything we've learned from NPM, if there's anything we've learned from Maven and Artifactory, the amount of complexity the developer has to deal with to start with is immense. If we can simplify how to bring together, time-tested, widely used solutions, the benefit is enormous. Now, manageable and secure. So, just as a off topic, I was talking earlier about why we started building this language. The goal that we had for this product that we're building in our startup, it requires a very, very high level of security. It requires a level of security where even two applications that happen to be sharing the same process space can't sense the other. So it's a fully containerized down well within a process space zone. So you could think of it as like anyone do low-level assembly, device drivers, stuff like that. It's like you have ring 0 and ring 3, and no one uses 1 and 2. But this is like ring 0, 1, 2, 3, 4, 5 to infinity. So each ring can create a ring or multiple rings within it. So it's an ability to completely compartmentalize from a security perspective. So when we say it was designed for the serverless cloud, that's not actually a marketing thing. That's exactly what it's for. And by serverless, I don't mean Lambda. Lambda is to serverless like a chariot is to a vehicle. I mean, it's such a tiny aspect of what a serverless cloud should be. When I say serverless cloud, what I mean is I want to write an application, not a function. I want to write an application, and I don't care, if it's going to be running on Amazon or Azure or Google or whatever. I guess I should plug my old company, Oracle Cloud. Anyone heard of Oracle's cloud? It doesn't matter where it's running. You shouldn't have to worry about like database. Like what's the proprietary API that each one of them has for their database, for their storage. Should I have to put my passwords into my source code so I can connect to the storage and all those things. As I say, Kubernetes is the most amazing piece of engineering I've ever seen in my life that should never have had to exist. And it's like the complexity that we throw at developers is enormous. So long-term goal, again, there's a difference between goal and reality, so I'll try not to confuse them. But the VM is designed for adaptive code generation, native code generation. So we don't do that yet. But the goal is to support LLVM as a backend, including WASM targets. So, and that's because part of the goal of this is to be able to take code that you're writing on the server and being able to reuse giant parts of that code for building even native clients down to smart devices. So, nobody says my baby's ugly. Yeah. To me, this is a culmination of many years of work, many years of effort, many years of thinking, mostly thinking. And, we wanted this to be something that would be beautiful, it would be attractive, right? No one sets out to make an ugly language except Bjorn Strustrup. And, but, you want it to be beautiful, you want it to be, but not just beautiful from a, wow, that's nicely formatted or something like that. Beautiful in terms of, when I first looked at Java, it was beautiful. When I looked at the source code for the JDK 102, like everything made sense. And so when I say beautiful, I don't mean, oh, they chose the most perfect keyword. I mean beautiful as in it translates the divine into the simple. And that's what a beauty in a language is. That's what elegance is. But it also has to be useful. Like it has to solve a problem. And I think if I'm lucky today, you're going to see that this solves some pretty amazing problems which is why we call it powerful, and efficient is not what it is right now. So our current runtime is a proof of concept, not a prototype. We're not that far yet. In fact, we're going to skip the prototype. It's a proof of concept, which means all it's trying to do is to prove out the specification, to show that everything fits together, so it becomes a truly type-safe, 100% verifiable language. But it's designed for some pretty amazing efficiency, and you'll see some of that today. So let's start with the simple stuff, get it out of the way. We stole the last remaining letter, single letter extension, so .x is Ecstasy source code, arranged hierarchically by package. Now, I'm going to show you just how bad I am at presentations by escaping out of this, and we'll just take a look at, a directory structure. So this is actually the core library. So you can see, if you look about 5 down, it says module.x. That's actually the module declaration file. We can take a look at it in the editor. This is an Ecstasy module. Looks like hello world, but more code. So this declares the module, and then when the compiler is running against a particular file, it walks up until it finds module.x, and then the packages are, the package.x located in the directory, because a module is actually a class. Package is actually a class. For that matter, a variable is actually a class. So everything's an object, everything's a class. Almost. There's a lie there, I'll show you. But there's hierarchical organization, not surprising. So you can actually define, you can put code, you can put state on the module in the package. Now, they're immutable, so once it's constructed, it's, so it's not a global. We don't have globals. One of the design requirements for a secure system do not have globals. And then when you compile it, it becomes XVM translatable code. So this is the portable binary. Very dense, very flexible portable binary. I talked about it on Monday, if you're interested, and I think that presentation's online now. And a module's dependencies are actually mounted inside the module. So you don't ever import com.whatever, I don't even want to go there. So basically what you say is, hey, this is my module, and I have a package called Bob, and Bob imports that module over there. And that's the only place you ever have to qualify a module name. Everything else is unqualified. It's all relative to the root of your module, or relative to the location of your code within your module. So it came out so beautifully, like I had all these complicated designs, none of them worked, and I just hashed it back and forth with some developer friends, and one day it just dropped out. It was so simple and obvious. It's well, I hope it's inspiring. OCD, what I mean by this is, I am not, as a longtime developer manager, etc., I have no interest in saving, a character or a line or something like that. I have interest in making code predictable and making it safe. So, things like if and while, they have to have an open curly brace after it. And, it's a choice. It's a very deliberate choice. And, I like Python too, but not everything gets, needs to be built in that manner. Overriding methods. If you don't specify add override, and it would hide a super method, it's an error. And interestingly, there are actually cases where you could put add override to mean, yes, I want to override that, or might not put add override, which means, no, I don't want to hide that. I don't want to cap that. Which, when you're dealing with covariance, when you're dealing with adding parameters and return values and subclasses, becomes pretty important. Switch blocks. You don't fall through switch blocks unless you say continue. If you don't say break or continue, it's a compiler error. These are just examples. There are 1,000 examples. I could talk about any one of them for 10 hours, but I only get 45 minutes. So, of course, inside a switch block, the braces are implied. because now that you have to finish it with a continue or a break or a non-terminating, I can't even remember the terminology, but like it's an implicit scope. Import names, they can be relative. So I already said you don't have to import com dot whatever. So not only that, you can actually import like your parent types, child, just by saying the name of the child. And if that name would conflict with something else, you can import it as some alias. And for those of you who have seen the code for coherence, you'll note that some of these ideas were ones we developed back in the 90s in the IDE that we use for building coherence. Assert, if you assert and you say, assert s not equal null, and it fails, it'll say, this is the assertion that failed, s not equal to null, and this is the value of s, null. Well, that was obvious. Things like that, though. I mean, it's about predictability. Nesting. Pretty much everything nests. Disgustingly so. So I pulled this out of a test. So don't write code like this. But this is not a variable. This is a property inside a method. So that property, if I call this method 10 times, it'll only initialize it the first time through, for example. And this one is a static property, meaning it's a constant static property. So static is not global. Static is constant. Let's see. Remember I said a lie, so that's the lie I was talking about. Pretty much everything in the runtime everything's an object. Yes?
I'm just wondering, why did you put private inside the function?
So why did you, that's an excellent question. Why did you put private inside this method? Because if I didn't put private, it would be a local variable, which is also an object. But in this case, I wanted it to be, so the private keyword denotes that it's a property. And in fact, you can only have private properties inside of a method. A method is, for all practical purposes, a package, as it turns out. It's a package, but it's opaque from a naming resolution standpoint. So I can build an entire class library inside a method, but it's only visible inside the method. And that's why this is so wonderful, is because if that's the only place I use that property, why would I want that property to be part of the API of the class that contains it? If it's only used inside this method, why not put it inside this method? Let's see. Metamodel. So everything's an object. But there's one case, in the loop case, it's not actually an object, it's actually a compiler trick. So we do very little what I'd call syntactic sugar. This is an exception. So if you look here, this is a loop, like a loop label like you'd use on a while or a for in Java. And I just say, hey, name of names, if this is the first one in the loop, add a comma. And in fact, like, I say it's syntactic sugar, but I can actually show you the type. That's label, right? Label has a first, so it knows if it's the first thing. It knows if it's it knows the number of count. So how many times has it gone through the loop? It knows if you're on the last thing. Now, if the loop doesn't know it's the last thing, then the compiler knows that you can't look at last. So this exists. This actually exists only for the compiler. Because at runtime, it actually resolves each of those properties to a automatically created variable. And if you don't use it, there's no overhead, there's no variable. These, a lot of these things, they're relatively small, but they're all things I wish I had a million times. And after you wish you had it a million times, you do something stupid like write your own language. So this looks kind of simple, right? Like I have a future int called sum. I'll do some calculation. There's a bunch of stuff going on here. Sum is the name of the variable, but what's the type of the variable? It's a trick question because there's actually two answers. When we talk about a variable, we actually mean two different things. We mean the value stored in the variable, and we mean the implementation of the variable. Now, normally, you have no control over the implementation. The implementation of a variable is It's an integer offset in a frame, right? Well, no, actually, this variable has a class. Not int, it has a class as a variable of, it's a variable of, a variable that incorporates a future mixin, and it's genericized by int, right? So the variable itself has a class. You're like, well, that's stupid. Why would you have a class for every variable? You know, because how many variables do you have in a typical application? I don't know, 1,700 billion. That's a lot of classes. Well, actually, the class doesn't exist unless you look at it, in which case it exists. In fact, the variable doesn't exist unless you look at it, in which case it exists. So when I say everything's an object, but most of them don't ever have to exist. Most arrays that you use will never exist. Most tuples that you use will never exist unless you look at it, in which case it exists. And that's the beauty of being able to define the virtual machine itself. And here, this is homage to K and R. That's the variable name. So normally if we say sum, we're not talking about the variable, we're talking about the number in the variable, the int, right? But if we want to talk about the variable, we have to have some way of saying, no, I actually mean the variable, and that's what the ampersand does. So we say, hey, variable containing the value of sum, because you're a future, the API on the future mixin, and by the way, when I say the future mixin, I mean actual, code. Do I have future? Yeah, there's future var. Remember the alias is on the import, so future var is imported as future. So when I say at future, it knows to use this mixin. This is a future mixin. Anyone who's ever written futures, hi Attila, this should look kind of familiar. And that actually becomes part of the class of the variable or of the property. All right. Let's see. Types. Let's talk types. So, again, I'm going to have to lie to you, but at least I'm telling you when I lie to you. We don't have anything except objects, which is, of course, a lie, because that's impossible. So we don't have int. We don't have Boolean. We don't have null. Like all the intrinsic stuff. We don't have word. D-word, we don't have little b byte, right? So how do you build anything if you don't have primitives? Well, remember the thing, like if I don't look at it, it doesn't exist? Well, let's actually run through a quick example here. How about, let's look at null. There's null. That's the code for null. Null is actually an object. It's an enumeration of one item called null. That was easy. So we don't have little n null because that's not an object. Who knows what the VM does? As long as it works like the code says it does, we're good. How about Boolean? We don't have little b Boolean, but we have a class called Boolean. Hey, it's another enum. That makes sense, right? False and true. So here's the API for Boolean. You can convert it to a bit, a byte, an int, a uint. You can and, or, and not it. And you see the default is false. It's pretty cool. And this is Ecstasy code. Looks like Java. Now, what's interesting, though, is that Boolean, I mean, obviously, there's only two of them, right? False and true. So it's not like a big overhead for having it be an object, right? But when you stop and think about it, you're like, there's a lot of cases where I'd like a Boolean to be 1 bit or 1 byte or 1 word. I'd rather not use a vtable dereference, right? So all of these things are designed so that any of these classes can be evaluated for collapsing, for flattening, for, I saw the great presentation on the Java inline capability, inline classes. I don't know if anyone who's here from Monday's presentations, but all of our classes can be evaluated dynamically for inlining. And of course, even though I said we don't have a little b Boolean, obviously the VM knows what Boolean is, right? Because some of the instructions some of the assembly instructions themselves have to produce a Boolean or take a Boolean. But Boolean is made of what? Well, actually, let's look at int. Here's int, and you notice that int's a const, so that's a class that once it's constructed is constant. Not too surprising. Java's coming out with a similar concept called a record. You know, I wish they would have used the same word because it would have made porting easier, but it's same concept though, which is I want to be able to define in very simple syntax something that once it's constructed is a constant value. So what is an int? That's an interesting question. But it turns out that an int is an array of bits. That's not too surprising. Well, what's an array? Well, an array, strangely enough, because we don't have an array, we had to write array. So, you know, in Java, array list is built on an array. But what if you don't have an array? How do you build an array list? So it turns out our array is a linked list. It's actually a linked list of elements. Now, that sounds really stupid because it is. So unless you look inside the array, it's not a linked list. But once you look in it, if you subclass array, which you can do, it's a linked list. So don't subclass array. But it's literally an array of bits. Well, what's a bit? I don't know. A bit is constructed on an int literal. What's an int literal? An int literal is constructed on a string. What's a string? Well, a string is an array of chars. I think we already saw an array. Char, what's a char? Well, a char is some sort of integer. And what's an integer? Wait, we were already at integers. So if you just followed this, I went through that kind of quick, but an int is made out of arrays of ints. There are a couple things in between, but an int is made out of several arrays of ints. So how big is an int? Do the math real quick. How big is an int? If you actually look at it, if you actually dive down in reflection and keep going, how big is it? It's infinite. A 64-bit int will use more memory than the entire universe has atoms. That's a big int. No pun intended. But if you don't look at it, it's not even an object. You look at it, you can look as deep as you want, and this is what we call the turtle's type system, because it doesn't stand on anything. There's this story of some physicist giving a lecture about the planets and the solar system and the universe, and afterwards this lady comes up and says, well, that was a very nice presentation, but we all know that the Earth sits on the back of a turtle. And the physicist, you know, being very kind to this nice old lady, said, well, yes, but ma'am, what does the turtle stand on? And she goes, oh, you think you're very smart, but we all know that it's turtles all the way down. And that's the type system. It is literally the turtle's type system. It stands on nothing but itself. It's as ridiculous a notion as bootstrapping, which comes from a French term, which is to pull yourself up by your own bootstrap. I think it's French. That's what I read when I was a kid. So the type system somehow doesn't touch the ground, right? You pick up a turtle, and there's always a turtle underneath it, and you keep going, and it's deep, and it's millions of layers deep. But in reality, the last turtle you picked up is the last turtle. Because unless you look under it, there's no turtle there. All right. Does that make any sense? That was not easy to build, by the way. So, as I said, it's just objects, no int, no boolean, no null, which now you know is a lie, because the VM is like, screw this. I'm not using an object. But this is what it means from a type system point of view. For you as a programmer, you're like, string, hello world. Well, that was easy. Looks like Java. How about string equals null? That's, well, we actually do we alias null as lowercase null as well, just in case you're like cutting and pasting code between languages. But as I showed you, that's an object. So this will not compile. Why not? Well, because some random enumeration called null is not a string. Just like, you know, I don't know, pick some other enumeration, like, you know, ordered or something like that. Like, it's not a string. You can't just assign an int to a string. Why could you assign a null to a string? Tony Hoare, you're welcome. String, question mark. what is string question mark? Well, string question mark is actually nullable or string. So string question mark is a shorthand way of saying nullable or string. So this type, that's an actual type, not a syntax sugar thing. This type is a nullable or a string. So I can set that to null, that's fine, which means this is just a shorter way to say it. And I can also, of course, set it to hello world. So a type, so in a lot of languages, type and class are the same thing. And often, even in Ecstasy, that seems true. But they're two distinct things. A type, if you think about like C++, a type is a vtable. It's a surface area of a reference that I have. It's the things I can call. It's the properties I can access. A class is how I composed that, how I glued together the bits and pieces to make that. So in a sense, you knew a class, you use a type. I don't know, I got to come up with some better ways of explaining this. Type systems. So a type represents the capabilities available through an object interface. So for example, when I have a class, I should actually show you this. It's pretty easy. Let's take a look at class. Why not? So class is parameterized by a bunch of stuff like a public type. So public, protected, private, it wasn't a security feature in C++, it wasn't a security feature in Java, and it's definitely not a security feature in Ecstasy. Pretending that access levels actually prevent access is the source of most of the problems in the universe. Ask Iowans. Public type, protected type, which extends public type, that's not surprising. Private type, which extends protected type, and struct type. What is that? Well, it turns out that when I construct an object, I'm not actually constructing the object. I'm constructing just the properties of the object. I'm setting the values. And so that's represented by a pre-object object called a struct. So here in construct, that was bad. In the construct function, it looks like we're doing this, but this is the struct, not the object. There is no object this yet. So it's as if after this code runs, we allocate an object and copy from the struct to the object, which of course doesn't happen because turtles. But that if you test it, if you build a test around it, we'll make the turtles and it'll look like that. And if you don't make a test, it'll be optimal. So those are types. This is a class. So class is about how we compose something, how we build something, how we design something. And type is about what are the things I can call. So a module, as we looked, it's just a hierarchy of classes. And modules can depend on other modules. We talked about that as well. But now, if I have a module, and it depends on another module, which depends on another module, and it depends on another module, we do something called transitive closure, which means we just follow all the pointers, and we pull them all together. Now, some of those could be optional. So, for example, I can say, I'd like to use that module if it's here, if it's available, if I have it, in my whatever, if I can get it from a local repository or something. Or we can say, it's supported, which means, yeah, if it's here, I'm going to take advantage of it. Why do stuff like this? Well, because if you have two library creators, they may have to work together when they're both in the same app, but they still have to work if they're not both in the same app, right? So we built that coherence product, and we had to work with Spring, and we had to work with Hibernate, and we had to work with Solar Metric, and we had to work with WebSphere, and we had to work with WebLogic, and we had to work with DUM, and we had to work with Sux. DUM and Sux were how we did XML back then. Apache DUM, Apache Sux, nothing, nobody? Okay. And it was such a pain in the keister because you couldn't bind directly to them or your code wouldn't work. So everything had to be via reflection. So what we do is we just make that part of the language, not reflection. Yeah, well, reflection is part of the language. What I mean is we say, hey, use this if it's here, and if it's not, don't. And then parts of the code can actually be reformulated during the linking to wire it in. So a container, once I pull all those modules together that I need, once I pull them together, link them together, verify them together, that becomes a transitively closed, immutable type system. And that's what we instantiate when we instantiate a container, a software container. I don't mean an OS container, by the way, much, much lighter weight. We'll have tens of thousands of containers inside a single process space. Like, this is a very lightweight construct. We instantiate a container around that type system. So this is just an example. I love this example, so I have to show it. Again, grabbing a keyword from C. Remember, we saw nullable, we saw Boolean. We actually looked at int literal as the thing that holds a string. FP literal is a floating point literal. Could be a decimal, could be binary, floating point, whatever. But these aren't numbers. These are number literals. String, these are JSON primitives. Okay? And a JSON document is either a primitive or a map of a string to something or an array of something. And what's the something? It's this. And I can actually take any object and say, hey, is this object a JSON doc? Like, that's actually a real, this is not syntactic sugar. This is real, a recursive type system built out of turtles. This, like, I don't know. I get high every time I just look at this. I've never used Ecstasy as a drug. I don't need drugs because I get to do this every day. Class categories. What do I mean by categories? Well, we've used Java, we've used C#, et cetera. Like, we know what an interface is, right? We know what a class is. Well, Ecstasy uses the same keywords. We added that const. I showed you that. Here's an example. I've been using this example for years because I used to have the keyword value, which I loved. You know, I'd say value, point, int x, int y. And we showed it to a lot of people, and they're like, value? You can't take the word value. Like, I use that everywhere. So we changed it to const. And enum is actually a const, but it's a singleton const. So to make something singleton, all you do is say static, so static const, right? But you can't say static class, because that would be a global. You can say static const, and you have an immutable const, or you can say static service, and that gives you a static, it gives you a singleton service. So what's a service? Anyone use Erlang ever? We're in Sweden. Someone has to use Erlang. A couple hands. Excellent. A service is an Erlang process, I think, is what they call it. An object in Smalltalk, a process in Erlang. It's something that, from a developer point of view, it feels like you're passing a message to, which sits in a queue, gets picked up by a thread, and then executed in some other context, which, like turtles, doesn't actually exist unless you need it. Service allows us to take a von Neumann machine and put it in a bubble that nobody can get inside of. The only way to get inside is to send messages. Now, how does a send message look? Actually, I have an example. Let's take a look at an example. I whipped this up yesterday, and not being one to ever want to throw something away, let's actually run something so you can see that this isn't all fake. So just a couple things first. So you can see here, instead of it.xquiz.testsimple, remember the module is the only thing that's qualified, so it's basically name dot something that you could feed into a distributed repository system. Like, it's designed for that. So this is a module. This is the entire module, and we're going to actually run it. But what we do when it runs, it goes through. This is a type. Actually, let's look at that. Just because I'm having so much. No, we're going to look at that later. So it's going to go through 1 to 3. It's going to format a string that's pound and that number, and it's going to format a string that's that number and an S because it's ISO 9601. It's that many seconds. So basically, we're going to say, hey, service 1 has a 1-second duration, schedule yourself. Service 2 has a 2-second duration, schedule yourself. Service 3 has a 3-second duration, schedule yourself. And this is the service. So what's a service? Well, if I were building it in Java, I would write a queue implementation, some sort of massive concurrent queue that does atomic operations, and I'd subclass thread to pick off stuff from the queue, and then I'd have some optimizations and whatnot, and then on the thread run, I don't know, it's more code than this. But what service is, it says, hey, I own data, and that's my data. Nobody can get to that data except coming through my front door, my API, my reference. This is a constructor. It's also declaring two variables. So ticker has a constructor that takes two parameters, and those two parameters are stored into those properties. So schedule says, hey, I need a timer. Why does it have to inject a timer? Well, because Ecstasy doesn't have time. Ecstasy doesn't have a console, it doesn't have a disk, it doesn't have a file system, it doesn't have a network. Anything it needs to talk to the outside world has to be injected. That's the security model. That is, there is no security model because there's nothing in Ecstasy that can do anything bad. So the only things that are bad are the things you inject in. Yeah, that doesn't sound good for a language named Ecstasy. So we inject the timer, we tell the timer to schedule using that interval. Tick, what's tick? Spoon. Nothing? Okay. What's tick? It's a function. I have to pass a void function here, so it takes this method, binds it to the this for the service, creates a function, and passes that function to schedule. And what does tick do? Well, it says, hey, I want to print, so you got to give me something to print with because there's no console. So we're going to inject one. Injection is like prayer. It says, hey, I have no idea how to do this, but dear God, please put something in my hands that I can print to. Oh, thank you. And by the way, if that can't be done, then the app can't be loaded. It's a contract on the container creation that all those injections are rolled up for all the modules that make up that container. And the container that hosts it has to agree to do those injections. And then we just print something out. So let's actually run this so you can see that I'm not completely making this up. So what we should see is 1 printing out more often than 2, printing out more often than 3. Now, in between those prints, what do you think's happening? There's these threads running, right? Waiting on something. No, not at all. There's nothing happening. Right? Yeah, there's some memory that hasn't been released yet because those objects are still reachable. But this is, what's the term? Reactive. There's no wait. There's no synchronized. There's no, well, there is a yield, but not what you think it is. There's nothing like that. These are completely event-driven here, and when they're not running, there's nothing running. Okay, let's go back. I'm like 1/4 of the way through, and we're like 90% out of time. We did service, right? So what's next? And a mixin. Oh man, these are awesome. We do not have multiple inheritance. Multiple inheritance is the bane of existence if you're a C++ programmer. Actually, everything in C++ is the bane of existence. Can you tell I have opinions about that language? I did actually write for many years C++ code and did not enjoy it. That's not true. I actually enjoyed it quite a lot until Java came out, at which point I hated it. So mixin is a cross-cutting functionality. In fact, we've already seen a bunch of mixins. At override is a mixin into a method or a property. At future var is a mixin into a var, right? So you've already seen them without even realizing it. Class composition, single inheritance, root called object, implements for interfaces. You don't actually have to say implements though, because interfaces are automatically duck typed, only interfaces. Delegates, it's just like implements, except you give it an expression, and everything in the type that you delegate gets routed to the thing you delegate to, not syntactic sugar. It's not code gen. Incorporates, or the at notation that we saw, to pull in a mixin. And we'll take an example look at that. Incorporates conditional. I say pure genius. I didn't come up with this idea, because I'd still say pure genius, but that would be kind of self-serving. Incorporates conditional says, hey, I need this functionality. Let's look at an example. Let's look at that 1.3, right? That would be called range. So what's a range? Well, it's a const of two orderables, right, of type element. You give it a first and a last, and it figures out if you actually gave it a last and a first, right? Look at this line of code. A range incorporates a conditional interval when element is sequential, which means based on the generic type, I could get a different class. Class is about how we compose, right? So if I say I want a range of int, I get an interval, which is a range. If I say a range of, I don't know, something that's not orderable, I get just a range that's not an interval. So that's why 1.3 is iterable, but range isn't always iterable because it may not be ordered. Did you get that? Is that, to me, that's like the coolest. Okay. So I have like 10 slides that say on and on and on. Let's just real quick say, so methods and functions, we actually have functions, not pretend functions, but real functions. They are, of course, objects. We have parameter binding, which means you can take something that has 5 parameters and bind the third one. Now you have a function that takes 4 parameters, which is called currying and binding, and we can pass by name. We can have default values for parameters. So instead of having 53 constructors, I can have one constructor with 53 optional parameters, and instead of passing them all, I can just say, hey, I want that option to be true and that option to be 7. So here's what an iterator looks like. And so this iterator uses another iterator. Look at the if. So there's a declaration inside the if. This is a conditional method. So next returns a conditional element, which means it returns a Boolean, and if the Boolean is true, it returns a second value. And because the language is type safe, you can't build something that looks at the second value unless the first value is true. So that's why it's done by if. It only gets inside if you have an element. That's why it's not a nullable element, it's an element. Here's another example. Assert does the same thing. It allows you to do a declaration inside the assert. So the compiler knows if you get here that this value too is of type, well, whatever it infers. Let's see, what else? Inject, we talked about that. Lazy, that's another one where I can basically, because a property in a variable is a class, remember, I can make it a lazy mixin that the first time you try to get the value out of that box that's that class, it'll run a calculation code, create the value, and store it. And in that case, the turtle actually has to exist because there's actual state to implement lazy. To do, oh, I love this one. I came up with this. I was so tired of like doing / to do, throw new unsupported operation. So to do is basically throw new unsupported operation exception, except it takes an expression, so you can put a string there, and it'll tell you which thing is not done. Virtual children, I'm not going to talk about because it'd be 6 hours, but it's pretty freaking cool. And operators, we don't have operator overloading because we have operators. There are no built-in, again, it's kind of a lie because obviously the VM knows about some of it, but there are no built-in types, there are no built-in operators. And implicit conversions. We don't have, when you say 0 in source code, that's an int literal, not an int, because implicit conversions are done by the compiler finding automatic conversions in the source code. Real generic types, fully reified, covariance for everything, but intelligent covariance. So it eliminates most of the compiler errors that would be related to covariant types. If you don't know what covariant types is, it's just a word someone made up to be really complicated. It just means that things work the way they should. So if you have an array of cats, it's also an array of animals, which is also an array of objects, just like in Java, unlike array list, where if you have an array list of cats, it's an array list of cats, and if you try to use something else, it'll kick you. Perfect type inference. By perfect, what I mean is there's no, it's a provable system. Auto-narrowing types. So in a class called Bob, if I return Bob, it's not actually the class Bob. What it says is this class. Internally, it compiles to a constant that says automatically narrow it. So as I override it, or as I mix in something to it, it incorporates that other type information into the signature, which is awesome if you've ever had to work with inheritance. Default parameter values we talked about. Overrides. So when I override a method, I can add a parameter as long as it has a default value. I can add a return type as well, so I can return more things on a subclass than were on a superclass. Now, of course, if you don't know about the subclass, you don't know about those returns, but it's like all these things are just so obvious. I've wanted, forever. There's just an example of what you can do with a switch. Switch takes multiple, this is a switch expression, but switches take multiple values, switch on multiple values. They take wildcards, they take ranges. This is a test. Never write code like this. This is awful code. So pros and cons. Everything's an object. Well, subject to a few lies. Incredible type system. Man, I love this types. I get so jazzed every time I work with this. Simple, powerful forms of composition. I hope I conveyed that with a couple slides. It's concurrent without threading. You saw that with service. Those were 3 concurrent services running. I didn't have to do any synchronization. I didn't have to do any. That was an async await automatically. If you want, you can use that future, which gives you a peek behind the scenes. And a natural progression coming from Java or C#. And the cons, nobody likes where I put my curly braces. The native runtime still needs to be built. And probably another con is we're out of time. So what can you do? Well, we still have a year or 2 before this is going to be ready for actual use. If this is the type of thing that excites you, we'd love, this is not a product for us. This is something that we're investing heavily in and we'll continue to invest heavily in for years and years. But this is something that exists for pro bono publius, for the greater public good. This is not a product. This is not something we want to sell. Here's a list of ideas, places you can get started. We got so many projects, so many things that need to be done, we'd love to take advantage of whatever talents people have. And if you're not interested in contributing, just keep an eye open. In a year or 2, hopefully this will be something you can actually use for real. 100% free and open source is all Apache licensed. We follow the Apache model for contributor agreements and all that. The only thing we've retained is the trademark itself, and that's only retained. We're not selling it. We just don't want it to be abused. We don't want someone to say something's ecstasy if it's not. Voila. Perfect?
Yeah, perfect, but no time for questions.
No time for questions. So with that, I will say thank you very much for laughing at a few of my jokes, and thank you.